Welcome to our next session. It's an observed relationship between current, voltage, and resistance. So this is where we'll start. If we had a voltage of 1 volt and the current was actually measured to be 1 ampere, then the resistance would be 1 ohm. If the resistance is fixed, voltage is proportional to current. That is, if you increase the current, if you increase I and you keep this fixed, that also V would increase as well, and vice versa. If you decrease I, V would decrease if you had a fixed resistance, right? So we can use Ohm's law to calculate current or voltage or resistance if the other is missing. So if you look at this here, we simply change the subject of the formula. So again, this is Ohm's law. It says that V is equal to I times R. Okay, so he observed this here. Again, if you move the 1 in front of each of them, this is what you get. Now you can change the subject of the formula. So you can have that I is equal to, you bring the V here, it's going to be V over R. And R is equal to V over I. All right, this is Ohm's law. And how do we use this? We can apply this to the load itself, or we can apply it to a power supply. And so I'm going to do 2 examples showing how we can apply Ohm's law to a power supply and how we can apply it to a load, right? So let's go ahead and start our examples. Here is the power supply example. So if we have a power supply here, and I know that we still haven't discussed AC and DC, we will get to it. So here we have a DC power supply, right? This is the DC source. And let me draw an AC source on this side. This is what an AC source looks like, right? So this is a power supply supplying AC voltage and current, right? If this is the power supply and we know that the voltage across the power supply is 50 volts, right? And we know that the current coming from the power supply, and notice here, before we show the electrons coming from the negative terminal, but I'm showing the current coming from the positive terminal. It comes to the same thing, right? Doesn't matter which direction we put it, it really comes to the same thing. And most math textbooks, they will actually show the current coming from the positive terminal, because it makes it a little easier just as a convention. But it comes to the same thing, whether you say the current comes from the negative terminal or the positive terminal. We know that the electrons are actually coming from the negative terminal going to the positive. But in most of our circuits, we show that the current direction is coming from the positive terminal of the battery. Just want to let you know that. If we say that the current is actually 10 amps, right, we can actually calculate the voltage here. Likewise here, if this is like a supply at our house, let's call this 115 volts, right? And in this case here, let's say we have the load that is going to be across this, and I'm just going to draw a resistor for the load. The load that's going to be across this power supply is 10 ohms, a 10 ohm load, right? We can then calculate the unknown, right? Here we are saying, what is the current? I is equal to question mark. Here we are saying that R is equal to question mark, right? We can use Ohm's law. If we know 2 unknowns, we can find the other, right? In this case here, using this equation right here, we can find that I is going to be equal to V over R, which gives us 50 volts over 10 amperes, which gives us 5 ohms. So the load here is actually 5 ohms, right? The load that is connected to this power supply. Likewise here, we are saying the voltage is 115, the load is 10 ohms. We can find I. Using this equation right here, you can see that I is equal to voltage over resistance, which will give us 115 volts over 10 ohms, which gives us 11.5 amperes of current. All right. So again, Ohm's law, very simple. It just says that the current is proportional to the voltage if we have a fixed resistance, right? And of course, most times in your circuit, your resistance will be fixed. unless you have a variable resistor. So like I mentioned, Ohm's law can be applied to the power supply. It can also be applied to the load as well. So say we have a resistor right here. Let's do another example. We have a resistor right here, and we have another resistor right there. And we know the resistance of this resistor is equal to, say, 1 kilo ohms. And again, that 1K is 1,000 ohms, right? And the and again, say maybe we know the voltage across this one. Say we took our voltmeter and we were able to measure the voltage across this resistor, right? And we saw that the voltage was 15 volts, right? The question would be, what is the current that is flowing through this resistor? I is equal to question mark. And let's say for this problem, we know the voltage going across this resistor here. So we took our voltmeter and we measured the voltage, right? We took our meter, we measured the voltage across this, and we found the voltage to be, say, 100 volts, right? And then we also took our ammeter and we measured the current flowing through this resistor, and we found that the current was equal to 1 ampere, right? We found the current was 1 ampere. We found the voltage across it was 100 volts. We can ask the question, what is R? R is equal to question mark. Now, of course, you can see simply by changing the subject of the formula, we can use our equations up here. These same equations, we're using them over and over again. You use them for the power supply. You also use them for the resistor itself. So in this case here, here's our resistor. We know that current is going to be equal to, I is equal to V over R, where V is the voltage across the resistor, which is equal to 15 volts, and R is the resistance of the resistor, which is 1,000 ohms or 1 kilo ohm, and that will give us 0.015 amperes, which is the same as 15 millivolts, sorry, milliamps. Again, a milli is 1 milli would be equal to 0.001. So you can see that this is 1 milli, and we have this here. This would be 5 milli here. So this is actually 15 milliamps. All right. On this side here, we know that resistance is going to be equal to voltage over current, which is equal to 100 over 1, which is equal to 1 ohm. Right? So again, this is examples in using Ohm's law, right? Knowing that simply this relationship right here, we just change the subject of the formula and we are able to calculate the unknown. Okay, so in our next lesson, we're going to look at power and also energy efficiency.